Good afternoon, everybody, and sorry for this pause and the wrong format of the slides. I think it happens sometimes. And soon enough you'll see that it's not the only fault here. So, what is Lua, what is luajit, and why it might be interesting, or it is interesting to port one to the other one. First, a few words about myself, and as you've already seen, I'm not really a software developer, so I know not so much about the software and spent last quarter century developing hardware where the software is usually runs on. And here it was different systems, embedded systems and system. Now it's system on modulus, and most of them are FPGA or SOC FPGA based systems on modulus. And yes, I can write some code on VHDL, but it's again not a software. It's more a description of the low-level hardware. And usual problems I have with the software is not how to develop the software itself, but how to make this software run on the hardware, and not just on the new hardware, but on the hardware which is not known to be working yet. And recent development, new architectures and soft core CPUs running on the FPGA are not making my life any easier, because now I'm not only not sure that some part of the hardware not working, but I can be sure that the CPU is also maybe not quite working right. So this talk is about the initiative project to port the Lua and specifically luajit implementation to the RISC V architecture. But for me, as I said, it's not interesting by itself, but to apply it to solve the problems with the early hardware bring up and with diagnostic and debugging this hardware. Unfortunately, this project at the, or fortunately for me, it's a very early stage, and it's not so many people involved in it. So please don't be disappointed by the end of this talk that nothing is available and nothing is working. It's more an lightning talk, why it might be interesting, what approaches to be taken, what benefits we will get if and ever it's done. Probably in this development room, nobody is interested to listen once again why RISC V is good, why we should use it, or anything should be ported to it. For the application of the hardware development, it's, and especially for the soft CPUs, RISC V is good because it's free and because it has modular and extensible approaches. So it's possible to take the core CPU, run some basic software. If the CPU is, or soft core CPU is good enough and is running, and the software in the state to bring up this non-working hardware and non-working CPU. And then you can build upon this solid foundation and to add some extensions both to your hardware infrastructure and to the CPU itself, because ISAR instruction set architecture reserved some space for the custom instructions and for the custom extensions of the CPU architecture. And why it's also important, there are already several hardware products from the company I'm working for at the moment, which do utilize the soft-core RISC CPU processors running on the FPGA SOMs. And later this year, the SOC FPGA with RISC V cores and system on module hardware based on this chip are going to be available. So we need some tools, we need some software to debug it, to demonstrate its operation, to test it in production. Okay, while Lua, 20 or 30 years ago, to bring the hardware for initial prototype hardware, I've been to exercise the hardware and test it. I've been pretty much happy to using Forth language. It's small, compact, easy portable to the new platforms, and it provides you an interactive tool to probe all the registers, to fiddle with your hardware, to see what actually is going wrong with it or going right with it. Nowadays, I think not so many people are writing any Forth, even less are using it in production environment. But there seems to be a better, also kind of niche alternative to that it's an Lua language. It's very small and compact, and it provides you an interactive environment where you can define new functions, you can touch all the pieces of your hardware. Since it's very compact POSIX C, plain C code, it's very easy to port to the new architecture. It provides an interface to C language, so if you can access some parts of your hardware in C, just map some registers and touch them, then it's equally well and easy to be done from Lua, from your interactive shell. And yeah, according to the interpreter language benchmarks, Lua, I think, one of the two on the top, if not the fastest one. But usually for those applications, it's not really critical. Anyway, you are typing on the keyboard much slower. And this approach with using Lua to bring up hardware and to debug it has been first tried by myself something like already 8 years ago to bring up and test the high-speed serial transceivers. But then it was a nice CPU, proprietary Intel, back then Altera. And definitely it would be much more interesting and sensible now to do it on the RISC V platform, just not to be connected to this particular hardware and particular FPGA vendor. Why luajit? Luajit is an implementation of the Lua language with the just-in-time compiler, very efficient, compact, fast, even faster than the Lua itself. But for me, the most attractive, if not the only most attractive or single reason to try it, was that luajit by itself includes a dynamic assembler. And that allows to experiment not only with something connected externally to the CPU block, but allows you interactively experiment with what is inside the CPU, to add some new instructions and so on. Of course, and for any real software developer, it would be probably much easier to add support for new assembler instruction in their binutils, LLVM, GCC, but all those things are way too heavy. And even if it would be possible, or if some software developer would be sitting next to me and doing that, it still would not be possible to experiment with those things interactively on the target. With the luajit and its built-in dynamic assembler, it's possible to write a piece of code with new assembly instructions you've just introduced in your softcore CPU and try them out to experiment with them. Also, another second order of importance reasons are that the luajit compiler is used in several interesting projects in software-defined radio, much smaller scale, but also interesting compared to the GNU radio, but still an interesting one, and provides somewhat more consistent and cleaner environment. Let's say Lua is 10 times smaller than Python, so Lua radio is 10 times smaller than GNU radio, maybe 100 times smaller. But then it's faster, it's cleaner, and it gets you better chances to understand what's going on really there. Tarantul database, haven't never ever tried it really, but what I read about it, it's a fast in-memory database and Lua application server. So for some high-grade loaded sites and enterprise level of applications. And also a nice compact Lua power distribution, which includes the dynamic assembler not only for the C preprocessing, but for Lua preprocessing. So it's just a compact cross-platform Lua distribution, also based on utilizing luajit. And if, as soon we have an luajit ported to the RISC V, all those and many other platforms and applications making use of luajit will be available or easily available. There are, of course, some downsides. Apparently, this project is not under active development. It's prime. It used to be mostly a single-person development, Mike Powell, and it looks like since 2017 he's not actively contributing to this project, but still taking some patches, and there were recent development of the ARM64 and MIPS 64-bit ports of luajit. Some of them were presented here on the FOSDEM 2 years ago, if I'm not mistaken. But still, the future may be uncertain, as with any open source and free projects. For the specific applications of the luajit, it's not uncommon for the companies to make forks and just to support their forks, not to contribute to the mainstream. And it both good and bad according to the MIT license. The Lua and luajit code is under. And it's somewhat lagging behind the mainstream Lua development, which is now it's the version 5.3. luajit is stick to 5.1, but it's not the only Lua-based project stick to this version, so maybe not. What is luajit itself consists of? As I said, the most attractive part for myself is the dynamic assembler. It's actually, it's a preprocessor written in Lua itself, which takes a mixture of C and assembly code and generate plain C code, which when compiled and executed generates a binary. So it's a kind of 2 or 3 step cross-compiling environment, and it allows an easy dynamic relocation of those steps either to cross-compile environment or to the target. And the Lua power distribution, luajit distribution, Lua power I've mentioned earlier, provides the same preprocessing not only for the C code, but for the Lua code itself. So you write the mixture of Lua and assembly, your target assembly code, preprocess it with dynamic assembler, you get the C or Lua executable. For C, you compile it and run it. For Lua, you just run it on the interpreter, either on target or on your cross-development host, and you get the binary for your target architecture. And with Lua, it's possible to run it, all this flow on the target itself. Then the Lua virtual machine, which is compatible, binary compatible by application binary interface and bytecode compatible with the standard Lua virtual machine, but it's highly optimized and written on the hand-optimized assembler and compiled with the dynamic assembler. And then there is a tracing JIT compiler, of course, dynamic memory management and garbage collector. And there are various extension modules, which are a foreign function interface. The ABI for the calling the C functions is the same for the standard Lua and luajit. Binary bit operations, which are now a part of Lua 5.3, but initially they were introduced by the luajit itself. And of course, there is a floating point support. Lua itself supports only a single type of the number, and it's a floating point. But for most embedded MCU class applications or embedded controller applications, you can skip all the floating point altogether and make your life much, much easier. Current status is a very short and disappointing one. Yes, Lua itself can be compiled and run on the both on the Spike simulator and on the target hardware. I've run it on several, I think 2 or 3 different soft core CPUs on 2 different FPGAs family. So there is a solid base for tests and reference platform to compare with, both in terms of the accuracy of implementation, correctness of the implementation, and in performance. Git repository fork changes, makefile changes to support the new architecture and build environment. So just the basic initial steps. Then the Git repository contains all the instructions from the base 32-bit integer set. Not much more than that. It's just 48 instructions, if I'm not mistaken. all the assembler, macro assembler stuffs, such as the registers renaming and handling, immediate arguments and labels, relocation handling is work in progress. So pretty much nothing is working. And everything else, or I would say 95% of work, is still in the long running to-do list. So if anybody is willing to join it and contribute to it, then you are more than welcome, either to fork it yourself or to send patches. As I said, the to-do list is much longer than the current status list. So what remains to be done is pretty much everything. No need to repeat that. But much more interesting where we go from here, when it's ready and when we have this basic core system is working. And those stuffs are really interesting. Unfortunately, we have to go through the porting and laborious efforts before we're there. RISC V Foundation resolves the J extension specification for the exactly for the JIT compiling languages. The question is that what languages are currently heavily using the JIT compilation. The most heavyweight player, I would say, are Java and JavaScript. Not sure, maybe C#. And obviously, because behind those languages, those environments, there are huge corporations with a lot of software, hardware developers, and some budget behind. Definitely, they will try to shape this RISC V J extension through the foundation, through their contribution. I'm pretty much sure that they're not aware of any efforts, but pretty much sure that there are efforts to support JIT compilation on RISC V for all those things. But so the question is who and in what direction will shape this J extension of RISC V architecture when foundation starts to work on it. And having a really smaller, lightweight luajit implementation might be an interesting test bench, and it would be great to have it before the extension itself is specified. So we can see if and how it compares to it. Then, of course, because we can change not only the hardware, but the CPU itself, and do it dynamically or almost dynamically, it would be interesting to experiment with the different hardware-assisted techniques for the JIT compilation to detect hot traces, because the luajit compiler is analyzing the execution thread of the virtual machine at runtime and compile the hot paths in this machine, and JIT compile hot paths, and some execution counter, performance counters in the CPU may be helpful to provide this hardware assistance for the hot trace detection. Same goes for the memory management and garbage collection with the hardware assistance for it. Then the thing which is really interesting is some custom and target application-specific acceleration development. And in this case, once again, the dynamic assembler would provide a very comprehensive and useful test and evaluation test and prototype platform, because you can just specify the new assembler instruction on the interactively on the Lua level and have it immediately compiled and have the binary code compiled in it and directly on the target. So if not in production environment and when everything is committed to the silicon, but for the soft core CPUs and the interactive development and debugging of those functionality, that would be really interesting. And since I've already mentioned that 30 years ago, Forth was a language of choice for such experiments, there is nothing that would prevent to write another Forth on the assembler, on the dynamic assembler of luajit. And then once we have an interactive Forth shell, it takes just 2 or 3 screens to write a new assembler on this Forth. And it looks like I'm going in the loops now. So, thank you for your attention. And if you have anything to contribute, any questions, please feel free to contact, to download, to scan. Yep. Thank you. Yes, any questions?
Assuming, well, first of all, hi, I'm Max. I'm working on the RapidJIT, another luajit fork, and I'm wondering if you're aware of what the other forks are doing at the moment. For example, in RapidJIT, something that we're working on right now, and I'm also going to talk about tomorrow, is we are porting the bytecode interpreter of luajit that's written in assembly to C. We're almost done with that.
Oh.
So that would kind of like save you porting the.
Yes, but for the so the question was if I am aware of what the other luajit forks are doing. Not really much aware of that. So I've seen that RK company, if I'm not mistaken the name, they are supporting ports of luajit to MIPS 64-bit and ARM v8 64-bit architectures. Tarantul, and they are mostly targeted on optimizing the performance for their database application. So I think they are providing some functionality which improves the in-memory database handling, and they've done it directly in the luajit. Then there was some other one, but you can talk to me either tomorrow or later today. I can find the link there and on some publications. Luavella, okay. I'm not going to elaborate about this one.
I want to say thank you. A very nice talk about what
Yep.
you're doing.
Oh, thank you. Just starting with that. And porting the virtual machine from the luajit virtual machine from assembler to C, yes, of course, that would save a lot of porting efforts. That would be much easier to port it, but then probably for the price of optimization and performance. Maybe not. Specifically for the floating point, as far as I know, the luajit is making use of non-tagging. Not sure how and if it's supported in your port. So thank you. I think, I'm not only started late, but I finished late too. Sorry about that. And I think it's in break now.
Yes.
Oh, so something all of us are really needed.
Okay,
Thank you.
Thank you.